In the last lesson, just so we have a bit of summary, we spoke really about something called box and whisker plots. So box and whisker plots. And we also spoke about, to draw the box and whisker plot, you need something called the 5-number summary. We also spoke about a few other things, but before we start, I want to know, what are the numbers in the 5-number summary? So you can put that in the chat, a little bit of a revision from the last lesson. What are the numbers in the 5-number summary? Pop your answers in the chat so we can all kind of see. So in the 5-number summary, we have the min, quartile 1, then we have quartile 2, or the median, Q3, and max. And that is fantastic, everyone. I love the answers that I'm getting in the chat. Now, if we take these 5 numbers, we can then draw something called a box and whisker plot, whereby this is the min value, that's Q1, that's Q2, that's Q3, and that is the maximum value. And sometimes what we like to do is we like to draw 2 different parts of the population on the same graph. And one of the nice things about the box and whisker plot is that it allows you to stack them kind of on top of each other, so you can compare 2 different data sets. Now, when we have a summary of a data set, and that's what we're doing with the 5-number summary and the box and whisker, we also talk about the distribution of the data, or the skewness of the data. And if we compare this little box and whisker plot that I drew, we can clearly see for the black box and whisker plot, the top 50% of the data is sitting over here, and the bottom 50% is sitting below the median. And because the data to the right is more spread out, we say that the data is skewed to the right. In the case of this one over here, not the green one I'll take away. And another way of saying that is positively skewed, And that is telling us that the data is more spread out to the right. The top 50% is more spread out over a bigger area than the bottom 50%, which is closer together. And we call that skewness. And it's a way of describing the way the data is laid out. Give me a thumbs up if you feel like you understand what skewness means, because we're going to do some questions now. Give me a thumbs down if you feel like, what is skewness? I thought skewers were to do with sausages or something. You know, like, give me a thumbs down if that word sounds weird. Okay. All right, so before we go on to actual questions about this, let's have a look at a couple of box and whisker plots. So if you look at these 3 box and whisker plots, they are different examples of what a box and whisker can look like. And what we see in figure A is that the median, which is in the middle there, that's the top 50% of data, that is the bottom 50%. You can see they're about equal, and so we say that the data set is symmetrical. Okay, so symmetrical. Whereas if we look at figure B, then the bottom 50% of data is quite compressed, whereas the top 50% of data is quite spread out. And so we say the data is skewed to the right, or another way of saying it is to say positively skewed. Okay, that's figure B. If we look at figure C, the bottom 50% is quite spread out, and the top 50% is more condensed, and we say this one is negatively skewed. So negatively skewed, or you can say skewed to the left. So whenever I just think, I say, look for the one that's the bigger one, the one that's more spread out, and that's the side that it's being skewed to. Okay, so now let's take this idea. Oh, before I move on, just to show you, in these data sets, each of these little pieces, like this is the top 25% of data, and this little bit over here is the bottom 25%. Okay. And this blue bit in the middle is the middle 50%. It's important that you know when I talk about part of the data that makes sense. Give me a thumbs up if you know that this is the bottom 25, this is the top 25, and this is the middle 50. If that idea makes sense to you, give me a thumbs up. Because in this section, people throw words around, and it can be a bit confusing unless you really go through each piece of the puzzle. Okay, fantastic. All right, let's look at this first example. And this is of a class, and it is the number of points that they maybe got on a test. Tell me, is this box and whisker plot skewed to the left or skewed to the right? Or is it positively or negatively skewed? Another way of saying it. Okay, so this is negatively skewed or skewed to the left. Fantastic. Okay, you guys have got that one. So I think you guys have actually got this whole idea. Yeah. So let's just do one more question and then I can move on. So this is a past exam question. And let's do this together. It says the 5-number summary of heights of trees 3 months after they were planted is the following. This information is shown in the box below, and we can see that this is a 42 and this connects to a 53. So that's over there, and this is in line with 50, and this seems to be in line with this, and this is in line with 23. What is the interquartile range for this data set? So that's question 1 from past exam. I think we've got 53 minus 42, which is 11. And so the interquartile range should be 11. That's where the middle 50% of the data is sitting. What percentage of plants, the second part of the question, what percentage of plants has a height in excess of 53 centimeters? So what percentage of plants have a height in excess of 53 centimeters? What do we think? Think about that question. Think about what the box and whisker actually tells you. What percentage of plants has a height in excess of 53 centimeters? Well, I can see the number 53, so it feels like all of these ones that sit in here will be in excess. Now, how big a piece of the data is this long whisker here? Well, because we know 25% is sitting in that green space there, we also know 25% is sitting in that space, 25% is sitting in that space, and 25% is sitting in that space. So because the quartiles, what we call Q1 is sitting here, Q2, Q3, then 25% is the correct answer here. What percentage of plants have a height in excess of 53? Well, the ones that are bigger than 53 are sitting here. Now that was tricky, but I'm hoping that with my summary here, you can see that 53 is sitting here, and we want to know how much of the data is sitting here. 25% is sitting over here. Okay, cool. Now, the last question, between which quartiles do the heights of the trees have the least variation? Between which quartiles do the heights of the trees have the least variation? Okay, so Keisha, if you look at a box and whisker plot, each of the the data is, each little piece of it has 25% of the data. So 25% is in that whisker, 25% is between those two lines, another 25% sits between here, and then the bottom 25% sits over here. So Q1 is like the dividing line between the lower 25% and then the next 25%. So now the next question also forces us to think about this. Between which two quartiles do the heights of the trees have the least variation? Where is the 25% that is the most squeezed? Where, if we look at the box and whisker plot, which part is most squeezed? Well, it's not the two whiskers, because they look very spread out to me. And it's not this bit, because that is quite big and chunky there. So it's going to have to be the 25% that's sitting here. And this is the median, Q2, and this is the upper quartile, which is Q3. And so it should be between Q2 and Q3. Okay, so we're really up to exam level questions and more interpretation there. So give me a thumbs up if you're feeling okay. Give me a thumbs down if you're feeling a little bit unsure. Orokanisa has asked, can I explain? So when we say the least variation, Orokanisa, the important bit is when you draw the box and whisker plot, remember this is the min, this is Q1, that's Q2, that's Q3, and that is max. And so when we say between which quartiles do the heights of the trees have the least variation, we mean where are they the closest together? And visually, you can see the distance between Q2 and Q3 is very little compared to here. Okay, so I hope that helped a little bit. All right, now the next thing I want to talk about, okay, and we'll come back to that, so don't worry if you are feeling a bit unsure. I want to talk about something called an outlier, all right? And in fact, you know what, actually, let me not do outliers now, because I think they might be trying to squeeze too much into today's lesson. Let me rather go to what I'll call grouped data. So let's have a look at, this is the main topic for today's lesson. So if you're unsure about that interpretation questions I just did, don't worry. There will be a recording that you can go back and look at. And I will come back to it later in the series. But for today, the main focus is on grouped data. So it says here, we have a list of areas in kilometers of the principal islands of the world. So these are like the big islands in the world. One of the big ones that I noticed that's near to us is Madagascar. And we've got the land area of each island. So we have something called Greenland, which looks pretty big. I'm noticing that the data is ranked from smallest to biggest. I also noticed that the island of Britain is, not actually that big an island compared to Sumatra, which is over here. So at the moment, these are a list of islands and their area in kilometers, how big they are is given. It says below that if intervals of 250,000 kilometers are used, in which interval will most islands fall? And what we're doing now is we're going from single lists of data. So this is a list of data that's ranked in order, and we're going to something called grouped data in a table. And what they're saying to us is in our table, we need a space for intervals. And the interval that they're suggesting is 0 to 250,000. I'm just going to remember that there's 1,000 there. If I then go to my next interval, it's going to be 250 to 500. And then if I go to my next interval, it's going to be 500 to 750. Then from 750 to 1,000, which is 1,000,000. And then there's also going to be, let's have a look at this last one over here. That seems a bit way out. Is there anything that big? Oh, there is Greenland. Okay, well, I guess we could go like 1,000 to 1,250. 1,250 to 1,500. Okay, and then 2,000. Okay, so if we have this list of data, and we did one of this in the very first lesson, if we want to do a count of how many islands fall into which category, we normally do a bit of a tally, and then we use what's called a frequency column, a count of how many things fall into each region. Give me a thumbs up if you're following my working so far with the changing it from a table, or changing it from a list into a table. Okay. So what I'm going to do is Greenland is going to get a tick down here because that's done. Then New Guinea, 789, where is 789? It's going to have to be here. So there's New Guinea. Borneo, 751. So that's also going to get there. Madagascar, 587. So 587 is there. Bufferland, and I don't know where that is. Sumatra, 422. So Sumatra has to be here. Honshu, sounds like Korean or something, 230. So that can be there. Britain is there. Victoria, that sounds a bit like Australia. Ellesmere, seems like it's there. Sulawesi is here. And so if I then go and I say, look, there are 2 islands that are between 0 and 250,000 kilometers squared. There are 3 there, 2, 2, and then there's going to be 0, 0, 0, 0, 0, and 1. Okay, what a lot of work, but it's important you understand. And so now we're in the land of grouped data. Which interval, on the question at the bottom, which interval will most of the islands lie in? Is it A, B, C, D, or E? In which interval will most of the Oh, did I leave something out? Oh, it's 4. You're quite right. Thank you so much. You're quite right. There should be 4 here. So in which interval will most of the islands fall? Well, it looks to me like it should be this one over here. So that's the biggest. And so which one is it going to be? It's going to be this one. All right. Now, we call this the modal interval, and it's kind of like the same way we can get mean, median, and mode for individual items. We can also get modal or measures of where the middle is for groups of data. Now, using what you know about, from previous lessons about finding the median, what do you think the median interval is for this particular data set? I've got things about the island. What is the median interval? And maybe somebody can even tell me what they think I need to do in order to find the median here. What do you think I need to do? What's important about the median? In this case, I have to find the median interval. You have to rank the data. Yes, exactly. So maybe we should count how many items there are. What is the N value for this particular data set, right? How many islands do we have? 2, 4, that's 6, 8, 10, 11. So we have 11 islands. In which interval is the median interval going to fall? Or on which item is the median? So we think about the position of the median. It's the 6th item in the list. Yes, the position of the median, the calculation we do is we go 1/2 times n plus 1. And in this case, it would be 1/2 times 11 plus 1, which is 1/2 times. So it's the 6th position. Now, if you count from the very beginning, you can kind of see that the 6th position will fall in this interval here, because 2 plus 4 is 6. Another way of seeing this is to complete a column called the cumulative frequency column. And the cumulative frequency column shows you how much you've got so far. So it would be 2, 6, 8, 10, and then it would just stay at 10 because nothing is being added. Then finally 11. And so the median interval would also be between 250 and 500. Give me a thumbs up if you followed how I knew that the median interval was the same as the modal interval. Just want to check. So we've done median and we've done mode. Now, what's the third measure of central tendency that we normally have to do? Who can think of what's the third measure of central tendency that the mean? Okay. Now, I'm not going to do the mean on this one, but I'm going to move on to another example, but we're going to work with that now. The mean, absolutely. Okay, so here is my example, and in this one, we'll do the mean as well. But first of all, it says, a choir teacher kept a record of the number of learners who attended the 40 choir practices during the year. So there were 40 times that the choir met. The number of learners at choir practice, so once there was between 0 and 10 learners at choir practice, so that was a quiet day at choir practice. On this, they were twice they were between 10 and 20. 11 times they were between 20 and 30 students, and so on. So that's what the table is about. Can you tell me what the modal interval or the modal interval is for this set of grouped data? And notice how I no longer have a list. I have an interval, and then I have the number of times the number falls in the interval. So what am I scanning? I'm scanning the frequency column. And it looks to me like this number is 14, which means it must be the one between 40 and 50. That is the modal interval. Next, I want you to find me the median interval for this grouped data. What is the median interval for the grouped data here? And what column can maybe help us? What did I do last time? I added an extra column. What was that column called that I added to help us find the median interval? Let me know in the chat if you can remember. It was the cumulative frequency column. It's like we count up the frequency. So 1, 3 plus 11. And this should always end up at the total because I'm counting up from the beginning. So what is the median interval for this set of data? Now remember, with the median, we normally have to do the position calculation first. So the position of the median comes from this formula. And we know that the n is 40. So we have 40 plus 1. What's that? 20 and a half, 20. So which interval do we think is the median interval? So I need to get to the 20th position. What group? So it's not in the first interval because there's only been one. Then I get to position 3. Then I get to position 14. Then I get to position 23. Oh, I've gone too far. Okay, that means it must have occurred in this interval. Because here I've only been up to the 14th item. Now I've got to the 23rd, which means I can't go any further. And so the median interval will be 30, between 30 and 40. So take a moment to understand the connection there, because I can see I've lost some students. It's the 20.5th position or 20.5 position. If I go to the cumulative frequency, there's been one item so far. Now there's been 4 times where this has happened. Now there's been 14. This is ranked in order. And so basically up to here, I've gone 14 positions. Now I've gone to 23. Now remember, I needed to look out for when I got to the 20s. So this is the first time I've got to the 20s. And which one is in line with that? It's going to be between 30 and 40. Now that is a little bit sneaky. Give me a thumbs up if you understand my logic. Give me a thumbs down if you feel a bit confused by that one. Okay. Fantastic. Okay. If you are confused, just hang in there. We're going to do another example of these after the break. So all I'm looking for is, because I don't have exact data items, I can see people are a little bit confused, so I'll go back to this after the break. But if you think of the cumulative frequency column, well, I'm basically saying, how far do I have to go before I get to 20.5? So think of it this way. Forget about the cumulative frequency column. So far, I've got 1. If I add 1 plus 2, I'm now 3 items through the data. If I add 11 to 3, I get 14. So now I'm 14 items through the data. Okay, now I add 14 plus 9. Oh my goodness, I've got to 23, which means I can't go any further. I've got to the interval that must have the median. And so that's why the median must fall in that interval. And what's new about this is, instead of dealing with exact data items, you're dealing with data within a interval. Why did we minus 50? We don't minus 50. This is the connection. So this is the interval 40 to 50 for the modal, and then median interval is between 30 and 40. It's just a notation that I'm using to say between 30 and 40. Mbali and Zanele asked, is it okay, instead of using the cumulative frequency column, if we just count the number of items? Absolutely, that's perfect. You can absolutely do that. Okay, you don't have to add the cumulative frequency column. I was just kind of sneaking it in there because I know it's helpful later. Now, before we have a break, I want to talk to you about the problem with the mean. If we have a mean normally, we go and we say, what are the number of items in the data set? And then we add up all the items. Right? So that's what we do for the mean. How many items are there in this data set? How many items are there in this data set that I'm doing at the moment? This one that the quiet teacher kept a record of. Okay, they're not actually 7. So there's 7 intervals. So there's 7 intervals of data, but how many actual items fall into those intervals? Okay, so there are 40 items. There were 40 choir practices during the year. And so the teacher has recorded 40 pieces of data that have gone into this table. So this will be 40. Okay, now, here comes the problem. If I want to know what the value of this one, so let me actually clear this out for a second. There was one time where between 0 and 10 students came to choir practice. But I don't know if it was 4 or if it was 7 or if it was 9. And so what do you think I should do when I want to add up all the items? Because I don't know if it was 0 or 9, or it can't be 0 because it's going to be greater than 0. But I don't know if it's 10 or 8 or 7. So what should I do to add up? Do we have any ideas about how we can maybe add this up? What's a good thing to do if we don't know the exact value, if it's sitting somewhere in this interval? Okay, what I'm going to say, Sadiq, I like what you did there. All I'm going to say is the first valid value in this thing is 1, and the last valid value is 10, because it's a person, and you can only come you can only be, it's what we call a discrete number. So what's halfway between 1 and 10? Or the midpoint between 1 and 10, we'll say midpoint. I think the midpoint, if I go 1 plus 10 and divide by 2, is just going to be 5.5. So we're going to use, I know it's strange, because here's the thing that's a bit tricky. It says here x must be greater than 0, and the variable is a discrete one. You can't have, oh, actually, you know what? You could, but you could have 0, but it says x must be greater than 0. And so the smallest amount of people that you can have that's greater than 0 is 1, and then the greatest amount is 10. So the midpoint is going to be 5.5. What is the midpoint going to be between 10 and 20 if the smallest number in the interval is 11 and the biggest number is 20? What's my midpoint going to be here for the second one? Okay, so this is going to be 15.5. Okay, and so that there are going to be two values of 15.5 that I would need to add up. What about this next one here? What is going to be the midpoint of the interval between 20 and 30? If the first number that's valid is 21 and the last number that's valid is 30. Now, okay, I see those answers coming in. Now I'm seeing a bit of a pattern. What do we think the next one is after this? It's going to be 35.5, and this is going to be 45.5. And then we are going to get 55.5. And so when we have to work out our mean, we are going to use these midpoint values as estimates of the values. Now, we're going to do that after the break, but I just want to check before we take our break, are we all okay with the thumbs up if you understand that data can be kept into intervals or groups, and that we have to estimate the value using the midpoint for the thing in that group? Okay. Now, if you're unsure, don't worry. We're going to do more examples. We're going to use our calculator after the break. But let's just take a moment to relax and unwind so that we can come back stronger in the second half. So I want everybody to stand up with me. We're just going to do a quick little exercise break. And what I want you to do is I want you to just swing your arms and just loosen up your shoulders. Okay. And then I want you to do some small circles like this. And then bigger circles. And then change direction with your big circles. And then small circles. Okay, then let's do a little twist, a little bit, or a rotation rather. Initially you rotate, and then as you get more relaxed, you are going to feel your body naturally going further. Okay, let's roll the shoulders back a little bit. And then let's roll the shoulders forward. Okay, so let's do some high heart rate activity. Let's do some skipping. We're just going to do 15 air skips. And we'll start in 3, 2, 1. 1, 2. And have a seat. Have a seat. And for today's brain break, I just want to ask you to solve this problem for me. So what do we think a Japanese flag plus 2 American flags is going to give me? That is your choice for today. Your little fun brain teaser. Conke has said 3 plus 3 is 6. And so an American flag is worth 3, which I agree with. Now, I think this is a Russian flag. Now there's 2 of them. So what does each Russian flag have to be? So Mbali and Zanele has said that 3 times 4, but now what does the flag of the, what does this whole thing, if that whole thing is 4, what does each item need to be? So it'll have to be 2 and 2 and 2. Now what is, yes. Now a Japanese flag is worth what? So it's going to be 12, because that times 2 is 24. So what is my final answer going to be? So 3 plus 3 is 6, and 12 plus 6 is 18. Yep. Where to, Sadiq, Conke, Mbali and Zanele, Amelo, you have nailed it. Well done. Okay, so I hope you enjoyed that brain break there. I want to come back to how we can estimate the mean. Now we're going to use our calculator to help us, but just to show you what we would have to do if we didn't use a calculator. Yes, Tando, can we unmute Tando? Tando's hand is up. Can you hear me, Tando? Okay, then just to show you what we would have to do, and this is where our calculator, which I'm going to show you in a moment, will really help you, is if we didn't have our calculator, what we would have to do is go, there's one value in this interval, and that is going to be 5.5. And then we have 2 values in this column, and our estimate is 15.5. So we would go, so 1 times that, 2 times 15.5. Yes, I see there are 2 hands. Kia, are you with me? So Pauletta, let's go to you first.
Good evening, sir.
How's it going?
Fine, sir. How are you?
Very good. What can I do to help?
So how did you get the midpoint? That's what
Okay.
I don't understand.
No, good question. So if you look at this interval, because x must be greater than 0, the smallest value that can go inside here, because it's whole numbers, it's numbers of people, is 1. And the biggest value is, so the smallest number is 1, the biggest value is 10. In the next row, the smallest number that can fit in between 10 and 20, that is a whole number, is going to be 11. And then the biggest number is going to be 20 because of this crocodile mouth thing here. And so all I'm then saying is what is halfway between 1 and 10? And the way I do that is I go 1 plus 10 divided by 2, which is 5.5. And for the next one, I go 11 plus 20 divided by 2, which is 15.5. Does that help a little bit?
Yes, thank you, sir.
Okay, now I'm going to show you how your calculator makes this super easy, but I just want to show you how much work the calculator is saving us, because I'm not even done. When I got to the next interval between 20 and 30, I would then have to go 11 times 25.5, and I'm still not even done. So this would take forever. So I'm going to show you a sneaky trick. So get your calculators out, and I am going to show you the ninja move on your calculator that you can do. Let's see, where's my, okay, so just let me know in the chat, can you see my calculator on the screen now?
Yes, it's on.
Okay, so what we have to do is we need to find the estimated mean. This is called the estimated mean, because we don't know it exactly, is we are going to turn the table function on in our calculator. So we go shift setup, and we get a rather strange looking screen here. And once you've done shift that, you have to click the down arrow. So down. Okay. Do that again one more time because it is a bit strange. So I go shift, setup, down. I actually have and then you hit the 3. Can you see, or on your calculator it might be different, but you should hit 3 for the stat. And it says frequency on or off. Now, in order to do a table, you need to turn the frequency on. So let me do this again. So I'm going to go. I'm at the very beginning, and I go shift, setup. And what I want is not there. I have to go down and get this. Then I click 3 for stat, and I turn the frequency column on. Okay, now, after that, let me actually even I'll get the little thing that I've got that actually shows you exactly what we're about to do now. Where was I here? Okay, so we do that. And what we need to do now is we need to put the data for this in my table. So I go mode, stat, and this is something which I can actually make bigger here on the screen. So you go to mode, so it's stat, and now you click var. And you're going to see that there's an extra column there for frequency. Now, before I even put the data in, can you give me a thumbs up if you are able to get to the stage that I'm at right now? Give me a thumbs up if you're feeling okay. So we've got to here. Now, to put the data in, you put the midpoints as which number is var. So let's go back. So we go mode 2 and you go 1 for var. All right, now for the values, you put the estimates of the midpoint. So we put 5.5 equals 15.5 equals 25.5 equals 35.5 equals 45.5 equals 55.5 equals, but we haven't got our frequency right yet. So what we have to do is go across. The frequency of 1 is fine there. This one should be a 2 equals 11 equals 9 equals 14 equals 3 equals. Now I'm going to wait. So how do we turn the frequency on? Okay. So I'll go back to that in a second because I want to do another one of these before the lesson finishes. I'll show you again one more time. I just want to show you this next bit. So I've put all the data in. I now want to go and get my estimated mean from somewhere. So I close this, I hit AC. And if you look at my instructions here, I go at the bottom here, it kind of is showing you what to do. Okay, so I go shift, stat, and what I'm going to do now is I press 4 for var, and then over here you can see the next value is 2 for the mean, and then I hit equals, and what I get is 36. Type 36 if you get that in the chat. We will do another one of these in a moment. I'll do another example with you. But just give me a 36 if you're okay with that. Okay. Now, what I think we've got about 5 minutes. So let's do one more of these so that you actually can really follow how this works and how this estimated mean thing works. So if we look at, let's have a look here. Okay. If we look at this situation, this is a different situation, and I want to forget about the mode and the median. Those questions you know how to do. It's the estimated mean I want to focus on. So there are 12 people between 0 and 10 years. Okay. Now, I'm going to draw a column for midpoint. Now, this is going to be a little bit confusing because you may think in this case, time is not a discrete variable. So time doesn't just have to be like 1, 2, 3, like a person. Time is a continuous variable, okay? And so in this case, the smallest value is going to be like really, really tiny, close to 0. And so the midpoint between 0 and 10, okay, just trust me on this for now. In this case, it's going to be between 0 and 10, and we divide by 2, and we're going to get 5 for my midpoint. And the reason it's different this time is that the nature of the variable is a continuous variable. So that you can come back to, and we can talk about in the next lesson, but let me just put in the midpoints for now. We don't have to debate it. So this is the midpoint of the interval. I want to see if we can use our calculators to help us get an estimated mean. Okay, now, if we go back to the beginning, I want to go out of stat mode. So I go mode 1, comp. And what I'm going to show you now is if you don't know how to turn the frequency column on, okay, this is how I did it. I went, so watch carefully if you don't know how to turn the frequency column on. Shift, setup, and now I go down. So the down arrow is important. And then I click stat or 3. And then I click frequency on. And now the frequency column is on. Now I have to log my data. So I go mode, stat, 1 for var, and there's my column. Now the values I'm going to put in there are going to be 5, 15, 25, 35, 45, 55, 65. Okay, now that is not enough yet. So I've said equals. I need to put my frequency column in as well. And my frequency column is 12. So equals 30 equals 18 equals 12 equals 9 equals 6 equals 3 equals. So now I put all my data. Now I want my estimated mean. I'm going to hit AC. I go shift 1. Then I go 4 for var. And I go 2 for the mean. And you should get 25.6667. Now, what this is an estimated value for the mean using a group data table. And all I need to do this is when I've got group data, I need an estimate for the value, which is the midpoint of the interval. Finding that midpoint will depend on whether the data is discrete or continuous. And we always pretty much find the halfway point. It's just a question of what are the end points that we use to find the halfway point. And so today, what we've done is we did some revision at the beginning, and we primarily looked at grouped data and how to find the median, the mode, and the mean of data when it's in a grouped data table. And that's really been the focus for today. And your quiz will be focused around that idea. There is a little bit in your quiz around histograms, which is a chart that we can draw with grouped data, and I'll talk more about that next week. Now, we've got a little bit of extra time. Are there any final questions before Piers shares the quiz? Because we have a little bit of extra time, and I know today has been a lot. So Tando, could we unmute Tando? Yeah, so Kia seems to be. Yeah. Hey, how's it going?
Can we go back to the question that we did previously? Because I don't understand how you got the modal.
Yeah.
And Yeah.
Okay. The modal interval is the interval that has the most things, right? So the modal will be the one between 40 and 50 because there are 14 items that occur between 40 and 50. So that's the modal interval.
Okay.
Perfect. Lovely question. Any other final questions before we put the quiz link out for today? All right. Well, then, Kia, can we put the link to the quiz in the Orokanisa? Let's go to that question. Cool.
Hi, sir.
Hey, how's it going?
Good, thanks. I wanted to ask, if it's district, do we have to look at the number? Okay, like 0 less than X.
Okay. When it's discrete, you can't have any fractions, right? So in the choir practice, right, number of learners at choir practice, you can't have 0 students. Yeah. Well, I suppose you could, but this particular limit is saying X must be greater than 0. And so you can't have half a student. So the smallest value that fits in here is going to be 1, and the biggest is 10. And so halfway between 1 and 10, you just add them together and divide by 2. And then
what if it's continuous?
And then for continuous, okay, which is like this one over here, which is time, even though it does say greater than X, you could have 0.0001 age. I mean, it would be unusual because it's foundation phase, but essentially it is possible to have a very, very number close to 0. And that's why we can use 0 as the smallest number and 10 as the biggest.
Oh, okay.
Okay.